Okay, what we're going to be doing today, we're going to be finding the greatest common factor of two numbers and then use that greatest common factor so that we can start into looking at the distributive property. So kind of going from a standard or expanded form to a factored form. So first we're going to take a look at the numbers 24 and 30. And we want to find the greatest common factor. And we've learned how to do this. I don't mind if the students use a calculator, but we would realize that the greatest common factor here would be 6. So we have a greatest common factor of 6. Now the problem here is 24 plus 30. Students need to recognize that they have two terms. The two terms they have would be 24 and 30. Terms are separated by addition or subtraction signs. And since our common factor is 6, we know that we're going to take a 6 for both of our terms, and we are going to be multiplying. We're going to be multiplying them by something, and our sign of operation will stay the same. Then you ask yourself, what do I need to multiply 6 by in order to have a product of 24? And it would be 4. And then what would we multiply 6 by in order to get a product of 30? And the answer would be 5. With this in mind, we can now see that the common factor for 24 and 30 by design is 6. So when we are trying to factor out the common factor, we can see that 6 times, 6 multiplied by a number is what's actually in common. So we are going to pull out that number. We are going to pull out that number, and the number is 6. So I'm going to say I'm going to take the 6 out of here. I'll take the 6 here. So I just pulled out that common factor, and we know that it's being multiplied. So we could put a little dot for multiplication, or we could just simply put our parenthesis, which implies multiplication. And then we look at what's left. Well, what is left? We have 4, our sign of operation, addition, and the 5. So we should be able to see that if we take 24 plus 30 and get it into factored form, we take our greatest common factor 6, and then we are multiplying it by what's left, which is the 4 plus 5. You can check your work. Order of operations tells us to do the parentheses first, so we have 9. 6 times 9 will give us 54. And if you look at the original numbers, 24 plus 30, that will give us 54 as well. And this is a correct answer. We just checked our work. The next thing that I'm going to take a look at would be a problem like this, where we're looking at 2 times the quantity 4u plus 2 minus 7. Now here again, we're trying to get into the distributive property. Order of operations tells us to do what's in the parentheses first. Because there's a variable in the parenthesis, now we have to use distributive property. We don't have a choice. And for right now, a good idea, even though we have that subtracted 7 at the end, we're not going to look at that. But what we can look at is to say everything that is in this parenthesis, almost like it's a basket, everything in this basket needs to be multiplied by 2. So if we decide to multiply everything in the basket by 2, I have 2 terms. I have 4u, and I also have a 2. So now I know I need to take my 2 and I need to multiply it by 4u. I can write this out as 2 times 4u. Keep the sign of operation, which is addition, and then I'm going to say that I need to take the 2 and also multiply it by the second term, so we have 2 times 2. And at this point, we can look at what's left, and we are going to be taking away 7. Students should start recognizing what terms are alike. Let's multiply first. I've skipped a step. 2 times 4u is the same as saying 2 times 4 times u, which will give us 8u. We'll keep our sign of operation. 2 times 2 will obviously give us 4, keep our sign of operation, and we're subtracting 7. Now this is when the students need to start looking at their terms. I have 3 terms. Again, terms are separated by addition and subtraction signs. I look at 8u. There are no other terms with the same last name. Therefore, the 8u will remain as 8u. Now, we're just getting into positive and negative numbers, integers. So we have left, we are adding 4, but we are taking away 7. So if we start with an added 4, if we look at an added 4 and we need to take away 7, we have an added 4 and we're going to take away 7. Let's take a look at maybe just a number line, and I'll draw a number line quickly. And let's just say that I have a 0, 1, 2, 3, and 4. If I, in fact, start out at 4, I have a positive 4. And if I say that I am going to subtract 7, we ask ourselves, what way do you go on a number line to subtract? Well, it would be to the left. So if I'm at 4 and I'm going to take away 7, I would be going 1, 2, 3, 4, which makes sense because 4 minus 4 would give us 7. But then we have to go 1, 2, 3 more, and we would end up with a negative 3. So our answer in this case would be 8u minus 3, and that would be our final answer. Done.